Hello, my name is Michael Murphy. I'm the GCP Practice Director at SoftServe. And today I'm bringing you a session called Ask SME. This session is mostly about Rob Martin's Digital Cloud Next session that he did, which I really enjoyed. And I wanted to talk a little bit about some questions that I think some people would have after watching the video, and just expanding a little bit more about it from my perspective. One could say that Google Cloud entered gaming in 2011 on the release of its Google Cloud platform, which was essentially Google exposing to the public internal resources for virtualization that they had been using for quite some time. As soon as the platform was released, several developers, technologists began to use just raw compute power in order to develop games and host game servers or game server capabilities. Google Cloud really started having, like traditional packages that developer could use, like options, probably in 2018. Two really important things happened. Both the release of Agonis, their service that provides matchmaking, which any developer can use to kind of just take a matchmaking service that is available and ready to use, bring their own logic to it, and have a working matchmaking service that they can integrate into their own game. Another important thing that happened in 2018 was Unity, the development engine, announced support, a plugin support capability for Google Cloud. So you could utilize Unity in order to you could utilize Google as a backend for whatever your Unity workload is, etc. In the last 2 years, they've had professionally marketed available options for game developers to utilize in their game development streams. Everything's changed. In original game development, games were meant to be single player, utilize the hardware resources that they were specifically developed for. There was nothing like cross-platform. There was no internet. As you can see, some of the games behind me, were never meant to be played outside of a living room. Today there are games, like MMORPGs have hundreds, thousands of players online at a time, sometimes working in tandem. You have matchmaking service. You have entire tournaments that can take place, from the aspect of a few gamers connected from their own living rooms. Everything has changed in technology and licensing and patenting, etc., etc. Game development companies have gone from relatively large, complicated, multinational corporations that you absolutely had to have the ability to produce both your own hardware as well as your own software to complement that hardware, to singular individuals being able to develop robust and arguably games that arguably stand against AAA titles. So really everything has changed. With the and I think it's really funny because I think games drove the change. Processors and video cards haven't gotten better because people needed to do word processing, faster or better, right? You don't need a $500 video card to edit cells in a worksheet. Games have driven technology. Games have driven the need, or even the concept and the inception of the internet. Most arguably, the internet's performance. I could say media use cases as well, but I still think that games have driven technology faster than any other medium that's out there. Chief among the things that have changed is the scale and multiplayer capabilities. And I really believe that GCP has got a great offering of multiplayer capabilities, as well as analytics, edge computing, all the things that are really going to be important to games in the future. Back in the day, at the time, I wish you could have utilized matchmaking services for Street Fighter 2 and be able to play somebody outside of your living room. I think a lot of people wish that for other really competitive games and games that were really large, like for example Super Smash Bros. Melee. One of the interesting things that actually happened kind of post-COVID or post-pandemic is that they introduced they actually developed a rollback netcode for Super Smash Bros. Melee, which is it's one of those games that's maintained the test of time. It's still a competitively played game, even if it's by a smaller niche market. There's still professional tournaments that are held every year, and during COVID, it really impacted individuals' ability to competitively play this game because it required local connection. You had to have all the players in the same room, and all the players had to have and you had to have a couple of CRTs, the GameCubes, etc., etc. One of the interesting things about technology is that they were able to develop rollback netcode. They already had for a while time there was a way to have a multiplayer play, like a lobby matchmaking style, but the technology was inferior to rollback netcode, and now there's great matchmaking services, and individuals who wanted to stay competitive and play Super Smash Bros. Melee, even though this pandemic is throwing everything off about local tournament play, local competitive esport type of gaming. They're able to do that on a game that is very old, a GameCube era game, and I think that's really interesting. And necessity is the mother of all invention. But if something like Agonis had been an option, to the development team, previously to that console development team back in the day, these wild steps and additional workarounds wouldn't have been required. COVID-19 has had a ridiculous impact, a tremendous impact on not only the supply and demand of gaming, but the culture and impact of gaming. Individuals who may have walked away from gaming because they didn't have time in their schedules, between work, travel, family commitments. Now that there really is no, there is no travel, there is no, there's no working late from the office and you're working from home. Certain individuals who had to put it away are able to partake again of a pastime that they really enjoyed. Those that already really enjoyed gaming, I would argue that gamers were some of the most prepared individuals for a global lockdown. Almost immediately after the lockdown, services like Steam were overwhelmed. Digital subscription services. There was a huge demand, an increase in gaming from all over. It has affected the supply and demand of like physical media, from Nintendo games all the way up to Switch games, even consoles themselves, modern consoles like the Switch. So probably the first two major games that were released after the global lockdown, like at least the United States one, because I live in the U.S., so that's the one I can really speak to. But the first major titles to release during the lockdown were the Final Fantasy VII Remake and Animal Crossing. Probably not the first two games to come out, but the first two major games. And, they were very successful, basically because people were bored and, wanted something to do. I was super excited about the FF7 Remake. And, it was a great way to spend a week. Animal Crossing has been hugely successful, and so much so that Switch sales immediately went up, and Switch supply demand was affected, and retail Switches are they can't keep them on the shelves, and on the secondary market they're fetching ridiculous prices, an additional $100, $200 per unit if you can find somebody willing to sell them. I've talked to other vintage game collectors, and just because of the supply, there's not as much of a supply, and there is a huge demand for older titles and vintage collections right now. So you see games like those rising in price, and I don't know that it's arguable that they might come down or might return. A bunch of collectors have espoused on that. They'll probably have a small reduction in price, but they'll probably have permanently gained, each game a few dollars, etc. And I think a lot of passions and, even for those that may have left hobbyist gaming, A lot of passion may be reignited by the individuals that have found the time for it, and that might continue going forward even after we get back to a new sense of normal, or what the new normal is. Google offers Unity, GCP as a backend for Unity. They offer Agonis, which is a matchmaking service. They offer traditional compute for traditional applications. They offer next generation AI and ML, global shard management, and edge computing. All right, we'll start with Unity. Smaller developers can use things like Unity to begin to develop a video game from, with no other resources other than Unity. And you can utilize Google infrastructure as the backend, so you don't have to have any physical hardware, in your offices, etc. So you can have a total cloud, pay-as-you-go, on-demand ability to start working on whatever game it is that you want to work on. Small developers can use Agonis, as we've kind of talked about before, to implement matchmaking services, multiplayer services, without having to do the heavy lifting and the infrastructure work that's behind that, as well as the development work. Really, all you have to do is design your own logic for how you want matchmaking to work for your game, and bring it on top of and put it on top of Agonis. Traditional compute, as we were hammering before, a pay-as-you-go model that doesn't require any investment in physical hardware, for network, for computation, for any type of online services that you might need. Traditional compute is there. Now, the next category, which is AI and ML. AI and ML really starts to get into outside of the actual game, unless you're integrating it. But this has to really do with understanding your customers, getting a 360 view of the data that you are collecting. You can start to collect player statistics and login times. Say you're trying to kind of find a model of how long your gamer base tends to play a session. Is there an impact? Does that change based on weather? Does that change based on other environmental factors, socioeconomical factors, etc.? You can start building those data models and graphs, and utilizing capabilities in that manner. Global shard management is a really interesting thing. It has to do with this product called Cloud Spanner. There's a great, just a write-up. If you look up Google Cloud and Pokemon Go, so Pokemon and Niantic used Google backend, notably Spanner, to develop a global database. If you think in development terms, you throw the Pokeball, you catch the Pokemon, right? These are global events that are happening at a massive scale, and it's writing to essentially, it's not writing to traditional, it's not writing to a traditional database. It's writing to a product called Cloud Spanner, which is meant for global scale and global operations. So with massive mobile games that are being written for next gen capabilities of global syncing, you can't use old technology. You need to be using newer technologies, purpose built for these capabilities. And one of the nice things about being able to get those services from somebody like Google is, if you're developing the game, you don't have to develop the infrastructure and the concepts and the technology behind that. You can just utilize what Google has on the table. And the last one is edge computing. This one is in its infancy, and it's not really being used heavily in games yet. But I think a lot of people have theorized and talked about edge computing, in a sense of, if you're developing a sports game and you want the ability to put a couple of cameras at the let's say it's a basketball sports game, and you want real-time statistics. Or real-time events that are actually happening at the games, say at the Spurs Stadium or the Lakers Stadium, etc. Eventually you'll be able to tie into actual things that are edge computing, things that are happening at the edge, and have those things in fact influence the game that you're playing. Maybe one team winning winning a game at a certain time might change who your next opponent is, etc. So I think it's a really cool application that could be used in the future. Rob Martin's take on simplification, right? And I think that's what Google's story has been, not only when it comes to gaming, but across most of the verticals that are available in IT. But how when you're selling a product, you want to make things simple. And I think one of the really great design concepts about Google from the beginning, if you think about just Google.com, the design of their search engine, the simplicity to that search engine, which is what made it so such a draw to people who were, if you remember back in the AskJeeves.com, Snap, MSN.com, MSNBC.com, etc. I mean, like older, busy, complicated search engines, and Google really just kind of took a simple approach, and they're still doing that today with gaming, even though it is a very very technologically minded deep process, but as a vendor, they're really trying to make the process simple, and give simple UIs, simple CI, really good development tools that are based around that, simple integrations with third-party tools that developers are already using, and I really just think they're trying to get the word out about that, to a field that hasn't necessarily used cloud for much more than online servers for game servers, and I think it's important that that message gets out. Matchmaking is matching two different players in different locations, right? So one player's on one Xbox 360 and another player's on another Xbox 360, and matchmaking is them entering into a lobby and finding each other, and both individuals are requesting to play against another individual, and finding those two individuals and establishing a connection between those individuals, and then allowing the math that has to work out for those for the game to be played over the network and over the internet, and then transmitted back across the network and then displayed correctly on each of their displays, right? So that's matchmaking. Matchmaking is making a match between gamers in different areas, and this could be like 1v1, 2v2, 3v3, or larger. Think of larger scale games like Fortnite, right? When you're creating a match, you have up to the maximum amount of players that can play that game that are kind of in a lobby, and then they're waiting to be paired together, and then for the game to launch. So Agonis is an existing matchmaking service that can be called into any level of code, into game development code, that already establishes the rules, the infrastructure, the back end, all of the components, and the difficult parts of matchmaking. So if you're writing a game and you're on a limited budget, limited time, limited staff, especially if you're a smaller startup, etc., you can just kind of call that service and bring your own logic to it. And the logic is the rule sets that you need for your game, right? Because every game is different, and you're going to need, you're matching one individual against another individual, or multiple individuals against multiple individuals, or you're staging, 40 to 50 people into one open world map, etc. And then what are the rules? What are the conditions? What security needs to take place? So this is the special sauce. The logic that is being brought into Agonis is the special components that apply specifically to your game. Heavy GPU requirements are meant for the part of gaming that's attached to your display, right? So behind me, I have a bunch of different consoles that are attached to displays, older displays, but displays nonetheless. That requires a heavy amount of graphics, because you're rendering graphics to the screen. When you talk about online services or dedicated servers for multiplayer games, not only for matchmaking but for open world games, MMORPGs, anything that has like a networking component that is doing math for multiple users at a certain time, that's compute intensive. It's not necessarily graphically intensive. Now, on the client side, the actual side that the gamer is on, that is experiencing the game, yes, the graphical capabilities are very important. It's a very big piece of the game. It's, think of like games that have a lot of rendering, a lot of high detail graphics, etc., etc. And as games continue to be developed with more and more modern capabilities, more and more physics, that's all important. CPU can actually be really important. CPU is still extremely important for local gaming, etc. Especially in open world games. All sorts of other use cases have high compute capabilities. But actually, for most online cloud-based concepts, where you're talking about game servers or just online portions of what's going on with gaming, you're actually talking about a much more compute oriented side versus a graphic side. Now, that can change with like services like Stadia, which actually do render. So if you don't know what Stadia is kind of trying to be like the Netflix of gaming, right? They're trying to serve games to your browser. So if you don't have a computer that has a graphically intensive video card, and you just want to do some gaming on your mobile device, or maybe your NVIDIA Shield or something to that effect, Stadia moves the graphic part to the cloud side, which is a really interesting component, and it has heavy, they have like Quadros, more professional GPU work series or whatnot, but it does do the CPU graphic rendering on that side, and then it sends a data stream back to the client, the Stadia client on the consumer, on the user side. So you've offloaded the graphic computation onto the cloud and back forward. That's important when it comes to Stadia or other use cases like that. It's not important when you're talking about like online matchmaking services for like Xbox or PlayStation games or PC games, etc. Heavy GPU requirements are meant for the part of gaming that's attached to your display, right? So behind me I have a bunch of different consoles that are attached to displays, older displays, but displays nonetheless. That requires a heavy amount of graphics because you're rendering graphics to the screen. When you talk about online services or dedicated servers for multiplayer games, not only for matchmaking but for open world games, MMORPGs, anything that has like a networking component that is doing math for multiple users at a certain time, that's compute intensive. It's not necessarily graphically intensive. Now, on the client side, the actual side that the gamer is on, that is experiencing the game, yes, the graphical capabilities are very important. It's a very big piece of the game. It's, think of like games that have a lot of rendering, a lot of high detail graphics, etc., etc. And as games continue to be developed with more and more modern capabilities, more and more physics, that's all important. CPU can actually be really important. CPU is still extremely important for local gaming, etc. Especially in open world games. All sorts of other use cases have high compute capabilities. But actually, for most online cloud-based concepts, where you're talking about game servers or just online portions of what's going on with gaming, you're actually talking about a much more compute oriented side versus a graphic side. Now, that can change with like services like Stadia, which actually do render. So if you don't know what Stadia is kind of trying to be like the Netflix of gaming, right? They're trying to serve games to your browser. So if you don't have a computer that has a graphically intensive video card, and you just want to do some gaming on your mobile device, or maybe your NVIDIA Shield or something to that effect, Stadia moves the graphic part to the cloud side, which is a really interesting component, and it has heavy, they have like Quadros, more professional GPU work series or whatnot, but it does do the CPU graphic rendering on that side, and then it sends a data stream back to the client, the Stadia client on the consumer, on the user side. So you've offloaded the graphic computation onto the cloud and back forward. That's important when it comes to Stadia or other use cases like that. It's not important when you're talking about like online matchmaking services for like Xbox or PlayStation games or PC games, etc. Lag really matters when it comes to online gaming. A few milliseconds could mean the difference between fragging someone or being fragged yourself. It's just really important, part of the user experience when it comes to gaming is to have a smooth online, gaming session. And, any network problems on either the client side or the server side is really going to just absolutely frustrate and ruin a gamer's day. So, things like utilizing Google's fantastic network services are really critical for game developers to be able to utilize, especially smaller. It's great for AAA titles. AAA developers have developed extremely robust delivery networks. And they've had problems. Everyone has, right? But if you think about Blizzard, really created a great online gaming experience with World of Warcraft. Xbox Live, PSN. There has been great solutions designed, but I would say that Google's networking strength, which they built for commercial applications, has humongous impacts on just on the gaming application. It's a fantastic network, and with the premium tier, you can keep the traffic on Google's backbone for like 90 to 99% of the trip of the total packet trip. Games are originally designed to be played, sitting across from each other. And as technology has taken us to greater and greater places, we're able to do more, and we're able to play with people, globally from across the world. You can have 5 individuals from across different places in the United States playing 5 individuals from different places in the United Kingdom. And it's fantastic that we can do that, but you absolutely have to put a strong network behind that, or you're going to have a bad gaming experience. For Tensor Processing Unit, which is developed and utilized as a hardware complement to TensorFlow and the operations of TensorFlow, which is really into a larger big data AI kind of discussion. I'm far from a absolute big data and AI expert, but TPU or TPUs are optimized for big data and AI, machine learning applications. This is becoming important for edge computing and other video gaming applications. So much like a GPU is designed for graphically intense applications, TPUs are designed for specific TensorFlow processing capabilities to accelerate TensorFlow operating. So utilizing it if you're going to pay for infrastructure, you're going to pay for infrastructure, right? You can build a workload and you can throw it at a CPU. And eventually you'll get the answer that you're looking for, most times, but sometimes you can have to throw ever increasing amounts of parallel processing or distributed processing and scaling and scaling up to get the results that you need. Much like in a given example, GPUs are optimized for like folding, right? GPUs are very are much better optimized for like Bitcoin mining or folding at home applications, etc. Because of how they're designed to work. TPUs are designed to be specifically complementative to TensorFlow and TensorFlow applications. And this is going to become more and more important for gaming in the future, especially as games integrate concepts at the edge and start to integrate data and data models into the gaming experience. Open up options for not only developers but for the entire entire game studios themselves. The ability to collect player statistics and player data and utilize that has applications across tournaments and competitive play, esports, historical archival information, You could utilize that data to increase to increase follow-ups to the individual game that to the initial release of the game. You can continue to collect data and statistics to improve the next iteration of the game, whether it be DLC or content, or additional patches, a sequel, other series in the components. Big data is just a field that's barely being tapped into to improve all of the aspects around gaming, not just the individual gaming experience, but a game studio being able to look at information about their players and decide how next to best, how to bring better experiences to those gamers themselves. In tournament play, it is, it's going to be really important for tournament organizers and for esports organizers to be able to crunch the incredible amount of data that is, just streaming in from so many different sources, and to be able to utilize that, for the viewership of esports, for esports casting, etc. It's going to be a really important component. And I think big data tools, and we've seen this actually in certain games, big data is allowing individuals to develop improvement engines and statistic engines for individual players, especially those who are really trying to stay competitive or analyze aspects about their game. There's use right now. I mean, it's an edge market, etc. But there are those that are actually kind of creating an API around the data that you can collect, like player data that you can collect from Overwatch, and you can run a client on your side and scrape all sorts of data from whatever session that you're in, and you can actually look at ultimate usage and what your win rate was over XYZ amount of matches, what hero selection did to your what hero selection does to your win rate or competitive rate, etc. Big data is this brand new field, and the ability to collect, chunk, process, do some machine learning on this data is an incredibly untapped field that has possibility after possibility after possibility. I think some of the most important fields that utilizing big data models against is going to affect is going to be esports casting, individual player metrics, and for opening up players to be able to kind of historically collect their own player statistics for personal improvement, as well as game studios being able to utilize game that they collect and store and have been storing for quite some time in order to increase in order to improve their game development capabilities for future games.